Alright, hey guys, we're going to start a new unit over moles, which this should sound familiar now because of the Edpuzzle we did. The first lesson is going to be kind of with just the history and just generally what a mole is. We're going to go in more depth on how to use them in chemistry and to figure out exactly what it means. Alright. So after today, you should be able to identify the key scientists in the development of the mole, use dimensional analysis to calculate how many atoms, molecules, or formula units are in 1 mole of that substance, and then use the correct number of significant figures units in these calculations. Alright, so we're going to go ahead and jump right in. There are substances, and we have substances everywhere, and you measure them all the time in different ways, like you count them, like you have 5 apples or a dozen eggs, or you weigh them by their mass, which are 2 pounds of bananas or 16-ounce box of cereal, or you use the volume, so like a gallon of milk, a pint of ice cream, things like that. The mole, however, can be related to each of these types of measurements. Alright, so we're going to first talk about the brief history on the mole. We're going to talk about a man called Avogadro, an Italian scientist who studied the behavior of gas. He theorized the volume of gas at a specific temperature and pressure contains equal numbers of atoms or molecules, regardless of the nature of this gas. This is what he looks like, apparently. There's 3 more. We have L'Archimede, who estimated the average diameter of a molecule in the air, was able to calculate the number of particles in a given volume of gas. And then you have Milken, who measured the charge of an electron from the charge on a mole of electrons. He divided the 2 and then obtained Avogadro's number. And then Perrien, who earned the Nobel Prize for computing Avogadro's number using many different methods, and named this consistent in honor of Avogadro. He used oxygen as a standard and proposed that Avogadro's number is the number of molecules in exactly 32 grams of oxygen. However, it is now considered that the standard to be the carbon-12 isotope. And our modern day definition of the mole is the amount of any substance that contains as many elementary entities as there are in 12 grams of pure carbon-12. Right. The mole, or MOL, as a unit in chemistry serves as a bridge between the atomic and macroscopic worlds. In Latin, mole means a huge pile. Right, so this is the mole. This is what mole stands for. 1 mole equals 6.02 times 10 to the 23rd. So this will be your formula for whenever you're trying to figure out how many moles something has. Which this is 602 sextillion. That's what that number is. That's why we use scientific notation. Alright, so the equality can be used as a conversion factor to convert particles into moles or moles into particles. So we're going to go over examples of both of those. The first one is how many atoms are in the 1.2 mole sample of sodium. So we're going to convert moles into particles, okay? So you have 1.2 moles sodium. You know that. You don't know how many atoms it has. So we're going to take 1.2 moles of sodium, divide that by 1, times that by 6.02 times 10 to the 23rd atoms of sodium, and you're going to divide that by 1. Mole of Na, because you're going to get rid of the 2 unit. This, we're going to cross multiply to get rid of 2 of our units. And then you just times right across and then divide by the bottom, which is 1. So you get 7.34 times 10 to the 23rd atoms of sodium. The next one is we're going to do particles to moles. So how many moles are equal to 4.79 times 10 to the 24th molecules of CO. So you know how many molecules you have. You don't know how many moles we have. So we're going to take our molecules, divide that by 1, times that by 1 divided by 6.02 times 10 to the 23rd, because we're going to cross multiply to get rid of our units, to get the 1 unit we want, which in this case is moles. So you multiply across, so you would do 4.79 times 10 to the 24th times 1, and then 1 times 6.02 times 10 to the 23rd. And then you would divide those two numbers and you would get 7.96 moles of CO. Alright. Your to-do list today, so sorry I didn't fill it out, is to do the following. Here, I'll show you. You guys are going to go to Canvas, which some of you have already seen it and done it from last week, so good on you. Good job. You're going to go to Modules. You're going to be able to see it. Publish all. So this is you. This is me, technically. Let's make it you. There it goes. All right. So this is you. You are on your chemistry page. The first thing you're going to do is read the encounter, the phenomenon, the mole. You're going to fill out the CER of the mole. And then you're going to do the Smart Book and do these 2 explore and explains of defining the moles. So these 4 things, this one is just reading, and this is where you're going to answer the questions. Make sure to fill out all the points for that. You can read defining the moles, and then do your Smart Books. Alright guys, that's all I've got for you today. Please work on this as we will be moving on. And you should have new packets. I will post it if they don't get printed off. Thanks guys. Bye.